Today we're going to be talking about preparing for the task of constructing GSL rules for assessing pre-deployment artifacts, and particularly those generated with Terraform, and to be generating this custom compliance content for use either in the CloudGuard portal or in conjunction with the new CloudGuard ShiftLeft command line interface, and specifically the ShiftLeft infrastructure as code blade. So we're going to very quickly go over some ShiftLeft IAC basics and talk about how ShiftLeft infrastructure as code assessments are automated, and we're going to compare that process to the more familiar mechanisms that are part of the core CSPM platform and the automation of policies or continuous posture activities in the platform. And we're going to mark out some important distinctions between those two, the way those two processes work. And that is going to lead us to a brief discussion of the input options that are available to users of the ShiftLeft and Terraform-based assessment capabilities, and also some of the requirements that accompany those options. And finally, once we have all that context in place, we will talk a bit about some tips and gotchas and potential workarounds when you're actually working on creating custom GSL rules for Terraform. Okay. Hopefully viewers will already be familiar, but basically ShiftLeft is the name of the new CloudGuard command line interface. This is sort of a multi-functioned interface. You can find it here in the primary menu for the platform. And it's named ShiftLeft because most of the feature sets or blades that are currently supported are oriented towards enhancing security for technical resources that that are in a pre-deployment state. So, in particular, we'll just be focusing today on pre-deployment cloud management templates generated with the Terraform tool. But there are several other blades that are currently supported by ShiftLeft and more still to come. But those are out of the scope of the conversation today. So the first step that you need to undertake as you set up ShiftLeft is, of course, to generate a token or API key in the platform. You're going to then want to install the ShiftLeft executable. Instructions for that are available in our online documentation. And then if you wish to generate results that are stored and persist within the CloudGuard platform itself, you're going to want to create a ShiftLeft environment. And a ShiftLeft environment is basically a bit different from how environments work in other contexts. You'll find ShiftLeft environment creation options here in the assets menu. And again, most of the environments outside of this context that you will see in the platform, these would be public cloud accounts, or with Azure, there would be Azure subscriptions or GCP projects. So again, these are important in the broader context because they generally represent the target for assessment activities when we're talking about public cloud, like sort of live environments. The environments are a bit different when you're evaluating pre-deployment artifacts, since there's no live environment. In this case, an environment basically just serves as a persistent repository or identifier for a series of assessment results that are generated over time. And you can create a new one basically just by providing a name to it and a description. You will basically get a unique identifier, which you will then use when you're actually assembling ShiftLeft CLI commands to execute and automate. And again, when you look at your ShiftLeft environment detailed view, you will see several tabs, just as you do with other environments. And this would include a list of policies or automated assessment workflows that are currently being executed that are targeting this particular environment, as well as a list of findings that have been generated by those continuous posture activities. So we're finally ready to actually start talking about assembling the elements necessary to actually execute a ShiftLeft IAC assessment. So the basic commands you can find once you have the ShiftLeft executable installed. You will execute this to get, this is the ShiftLeft CLI wide options, and we're going to be working with IAC assessment. And you have a set of features here. A typical ShiftLeft query is going to look, it's going to have a variety of elements. First, you want to toggle the, you have to call on the specific blade, which is IAC assessment in this case. If you want to set the debug flag for maximum feedback for troubleshooting, it's uppercase D. If you, this is a timeout period, it's typically set at 600 milliseconds. I've expanded it a little bit here just to make sure to give assessment plenty of time to run for a couple of larger tests that I have constructed. You have to call out Terraform in particular now, as since we have just introduced support for CloudFormation templates. Now, if you have created a ShiftLeft environment, which will basically provide you with a continuous identifier that's associated with whatever assessments that are executed that reference that environment, that you would actually put the identifier, the environment ID here. And then the next element would be the compliance content. Here I've actually used the lowercase l flag and inserted a single GSL rule. The more common use, of course, would be to reference a rule set. It's a predefined set of GSL rules that have been created specifically for the platform in question. In this case, the platform we currently support the three CloudGuard managed rule sets that are specific to the Terraform platform. Since I'm basically set up an AWS Terraform repo for this demonstration, I'm going to be selecting the Terraform AWS CIS foundations. Okay, so once let's just go ahead and take one of these commands. We're going to, again, there you have a couple of different options for the kind of inputs, Terraform artifacts that you actually want to target for assessment. Right now, we're going to target a Terraform directory or repo for assessment. It's a very simple one. There are other options. I will explain what those options are and why they're important momentarily. But so here's a typical command. You execute that. And this is just with a single rule I'm testing. And it turns out that this rule, which leverages a syntax that we have developed that enables you to link two separate resource definitions together. So you can describe a requirement restriction in terms of the relationship between two separate resource definitions that appear within a single cloud Terraform repository. And in this case, this is testing for the relationship between where CloudTrail trails are stored, which S3 bucket they're in, and whether or not that S3 bucket has sufficient access safeguards against unwanted public access. So in this case, this resource failed. And if we were to look at the actual Terraform code and that repository and go looking for verification for this, we would find that this trail is stored in this S3 bucket. This S3 bucket, again, these are two resources that are defined independently of each other. They just happen to be in the same, defined within the same terraform.tf file. And in fact, the S3 bucket is currently configured to launch with public read access. So that appears to be a true positive check. So that's assessment is working correctly. Now, the more common use case for ShiftLeft IAC assessment is going to be to execute an assessment with a predefined rule set. We'll try one now with the CIS benchmark for AWS Terraform. And what this generates, as suggested up here, is you basically get a series of results. And in this case, the assessment failed. Now, if we're using this, in the expected most customary way of using this would be to make this a part of a CI/CD pipeline process, where the details may not matter so much on the fly once you've decided how you want to react to the results. You basically you can use a couple of additional flags that are available in the ShiftLeft configuration, for example, to decide whether the result that will be returned will be assessment passed or failed. You can basically modulate that based on whether or not a non-compliant observation is associated with a particular severity level. So you maybe say only assessment results rules that have a sublevel of critical that return a non-compliant finding should actually trigger a fail. The rest can maybe be used for informational purposes only. Maybe maybe rather than a critical, maybe say you could elect to say we will only trigger a pipeline halt in the presence of one high SEV non-compliant observation, or perhaps more than one. Maybe you say a minimum of, if there are more than three or more non-compliant observations, then at that point you would trigger, you interrupt the pipeline and return the Terraform resources back to the relevant developer for a correction. And these are basically parameters that you can fine tune with the ShiftLeft CLI options. Once you have set up your compliance content and you've determined exactly what role you want ShiftLeft to play within your CI/CD process. Well, although we assume that primary automation is probably going to be integral to the customer's CI/CD pipeline, we do support some customary workflow automation capabilities within the platform itself. Most of these will be will leverage the familiar modular elements that most customers will be familiar with, from setting up CSPM automated workflows that target live environments. So in order to create a new continuous posture or policy, you would choose a target. In this case, we'll just do a single environment, level 1, shift left. And we will select one of the environments I've created. And let's just choose, for simplicity's sake, the CloudGuard Managed CIS Foundations again. And then the output. So again, all these elements are the same that you would be familiar with from the core CSPM for the CloudGuard platform. And we basically have now set up a new automated workflow. So it's going to execute the assessment that you've set up at the normal cadence. And it's going to basically preserve, if you've in order to set up an automated workflow here, you have to actually define a shift left environment, and that again will be the kind of persistent identifier associated with all of the non-compliant findings that are generated that are forwarded to that environment over time. Now, again, worth noting that again that environment, the term environment is used here doesn't have the same exact meaning as it does in other contexts. The environment is just used to store or to locate shift left related assessment outputs. So again, given the role that shift left environments play in automation, we would generally recommend that if you want to have easily interpretable shift left generated assessments results persist in your CloudGuard platform, you might wish to consider creating a separate shift left environment to store each distinct kind of shift left assessment that's for each distinctive, say, assessment execution context, which would mean typically a set of targets, Terraform repos or plan outputs or whatever, and the specific assessments you're applying against those. If you for each of those pairings, if you create a separate ShiftLeft environment, you can be assured that when you go back to look for results that are specific to a particular environment and a particular assessment instrument, compliance content, a rule set, or rule, that those will be easily discoverable. And of course, the variety of options you would have for automating shift left activities as part of a CI/CD pipeline are very wide and diverse, and would depend entirely on the other elements of your pipeline. Now, before we get into the nitty-gritty for details for creating custom content for Terraform, it would be useful to very quickly review one or two important distinctions between how assessment works in live cloud environments, right? The kind of CSPN functions that have been integral to the CloudGuard platform for years now, and the distinction between how that works and how assessment works with pre-deployment artifacts. So with the let's call it core platform CSPM functionality, really can think of it as being the product of four key elements. We have a very, very extremely user-friendly query construction interface. We have a very user-friendly query construction interface. It enables you to leverage any one of hundreds of predefined, ready-to-use cloud resource-specific security context models. We have a query constructor, which employs a syntax that's GSL government specification language, which basically produces near plain English query statements representing requirements or restrictions that you want to verify and enforce in your public cloud environments. And this is very transparent and easy to understand for pretty much any relevant stakeholder. And again, there are just lots of features that are built into the query builder interface that are designed to make it very easy to use for almost any stakeholder. And of course, we've already spoken briefly about several of the other modular elements of our assessment workflow automation mechanism. So this is the GSL builder, and rule sets would represent our compliance content management interfaces. We also have the notification management interface, where you define and manage your different output preference sets that you want to associate with automated compliance assessment workflows. And when you are ready to set up a new automated workflow, the policy or continuous posture mechanism enables you to independently select the compliance content or rule sets that you want to activate, and then pair them with the output preferences that are specific to this activity, and then to target those two elements against one, several, or even potentially all cloud environments that are for the specific cloud platform that you are evaluating. And And once that happens, basically that workflow will be executed on a recurring periodic basis, approximately once per hour, and generate whatever outputs you have specified, in addition to depositing a snapshot report in posture management assessment history, and in many cases, generating findings which are appended to the continuous posture findings interface in the events menu. And those outputs can be further fine-tuned to align with your own security goals by applying exclusions to particular finding generating patterns, and or to select particular patterns. You also have the option of selecting certain finding patterns to trigger automated remediations using our CloudBots functionality. Now, there are a couple of important differences in how the CSPM works when the context is pre-deployment infrastructure as code. The most important one for purpose of this discussion is that it's not possible for us to provide predefined security context model as we can in for live environment assessment. It's just a range of variation in organizational use cases and implementation patterns for infrastructure as code tools like Terraform are just way too broad. It would just any static model that we defined would have extremely limited use for most potential users. So instead of attempting to pre-assemble models, we actually assemble entity models dynamically based on the infrastructure as code artifact that you choose to evaluate, that you basically upload for evaluation to the platform. And that's going to make the choice of assessment artifact uniquely important in this context. And I will provide an illustration of that momentarily. Okay, so let's take a look at the input options that are currently available for Terraform assessment, and particularly that are relevant when you are ready to start constructing custom assessment content. At present, we support two general kinds of assessment inputs, and that would be Terraform, basically project files or repositories, and Terraform basically planned output, execution plans. Now, important details here. In order to upload and evaluate any Terraform artifact in the portal using the GUI, either when you're looking at details in the GSL builder, or if you want to execute a manual assessment using a Terraform targeting rule set, and you want to just apply it directly to some Terraform either repo or planned out, you always have to upload the assessment target in a compressed as a zip archive, basically, and the zip archive would include your for project files, it would be the folder or directory, and your main.tf file or equivalent. And you want to be a bit careful about including other kinds of files in the target project directory. Just to bear in mind that there's a 30 meg upper limit on the size of uploads, and so if you were to attempt to zip and upload a project repo that contains the sort of top level .terraform directory that contains all of the Terraform provider modules, could be 100 or 200 megs in size, that will not work. That will trigger a failure. So it's probably best to keep the directories that you upload for assessment, in particular for just GSL rule construction, as simple as possible. For Terraform execution plans, now these need an additional processing step in your local environment before you can zip and upload those for assessment. And specifically, any assessment plan that you want to evaluate must first be converted to JSON format before it's zipped. And again, in a minute, we will look at the Terraform native command that you would want to use to convert the standard plan out. You don't want the binary or the kind of text output that the CLI will generate when you execute a plan, Terraform plan command. So when you're ready, you basically just upload. You'll have to navigate to the relevant repository. I have set up some resources that I've already prepared. So I'm just going to actually show you that. Once you have uploaded an assessment target, whether it's a project repo or plan out material, you can refer back to that over time. So I'm just going to leverage the one of the artifacts I've already uploaded, and I'll start with the project repository. So this is the GSL view of the project repo that I kind of showed briefly earlier, and notice that basically these each of the resource definitions, it is the GSL properties, which represent in most cases configuration states that correspond to configuration states in the cloud native environment, or in some cases they're synthetic values that the CloudGuard backend generates based on after some analysis of the cloud native states that we collect. You see, with project repo files, they relatively provide a relatively sparse level of or coarse level of details that you can leverage for assessment. Now, let's take a concrete example. So S3 bucket. All right, expand here. So here are the available parameters that you could reference and when you're creating a new rule. Now, if you're using project directory project files, now I'm going to illustrate the difference. I'm now going to take the same, I'm going to use the same basic input. I'm just basically using the same project repo, but in this version of it, I've actually executed the Terraform plan command, and once that's completed, I used a Terraform show dash JSON, and then output the results as a JSON plan out JSON, and then uploaded that. Now, we would actually recommend in most cases that if you can, you use plan out as your assessment input, at least for developing rules, and that's because the Terraform plan command basically renders the cloud resources that you would define in such a way that makes the relationships between the resource definitions more explicit and more transparent to the posture management engine. So basically, you have a lot more details that you can leverage. And just a kind of very casual cursory examination. I guess we have about twice as many options that we can evaluate. And again, this is a very, very simple Terraform project environment that we're looking at. So those are your two options, the basic options. Now, in terms of if you are just getting started with Terraform and you already have a live environment, or you're just getting started with Terraform GSL rule creation, there's an additional step you might wish to consider in your native environment that will provide for even a richer set of inputs that you can leverage when you're creating your own content. And that would be to use either the Terraform native import command to create a kind of shadow representation of all of your Terraform defined resources, basically to render that in a kind of mono repo form. And then you can do that with the Terraform import command, but it requires a bit of work to do that. An alternative option would be to leverage a tool that has been made publicly available by Google called Terraformer. And this is actually largely designed to make it very easy to generate mono repo style configuration templates, including in Terraform, for supported cloud platforms. So this is the kind of tool that you could use to execute in a more complex, against a large number of public cloud resources, and it would complete most of the work necessary to generate a kind of mono repo style representation that you could use exclusively just for GSL rule construction, if you wish. And just to illustrate the difference that would make, and let me try. So I did create a kind of monolithic representation of a large number of resources that we have in our live demo environment for AWS. And that's here. And the utility of this is you will get a flat representation of all of the, basically of every Terraform resource that can be derived from the live public cloud resources that you have imported in a single view. And each of those, so these would effectively represent all of the Terraform for AWS entity models that you would have available to And let's just look again. If you have, if you would import a large number of live S3 buckets from some environment, and each of them has a slightly different set of uh, uh, Terraform interpretable configuration states. Well, when you complete the import, you would have access to all of those configuration states in every S3 bucket that you want to evaluate. So again, this is going to give you the richest set of inputs that you at your disposal for creating custom rules. Now, again, if you're starting with a Terraform repo that you already know produces live environment that exactly matches your desired target state, then I'm taking the additional step of creating a kind of a mono repo just for rule construction, but not necessary. You can always just use your repo that you know is quality to produce requirement style GSL rules. But again, this just gives you a lot of flexibility when you're exploring the kinds of requirements and restrictions that you want to apply to your pre-deployment Terraform artifacts using ShiftLeft or the platform itself. Okay, so that covers all of the available input options. And let's talk about the requirements that are specific to each. If you are working with project files, again, just to recap, you're going to want to, the target should be a folder or directory that contains one or more .tf files. These typically would be main.tf and perhaps a few others. As a general rule, you probably want to avoid using directories that would contain a lot of hidden folders or content that's generated by the Terraform platform, including the Terraform provider modules and state files. Again, this is just you would not want to upload something that is exceeds 30 meg because it will not work. When you're working with Terraform project files, another limitation is when working with platform problems, the assessment will not work, will not run to completion and produce valid results if the files, the contents of that directory contain any sort of cross-file or cross-directory references. So that means the project file-based assessments will not support directories that include locally defined Terraform modules or that leverage Terragrunt or any other tool or mechanism that allows you to define variables in one place and apply and reference them elsewhere. You can include a hierarchical directory, a folder that contains one or more levels of subfolders. But when you're executing assessments with using project file as input, each directory is going to be evaluated independently and you actually have to explicitly specify an entry point as a part of that assessment execution command. That's important again. So now for requirements for evaluating execution plan Terraform inputs, again, you must convert to JSON before you upload or before you actually archive the file and upload it. Now, in addition to making the inter-resource relationships more transparent to our posture management engine, another significant advantage of using execution plan inputs is that basically, in this context, you can use this is compatible with source Terraform content that includes things like locally defined modules. So, because again, all those local references are going to be rendered explicitly in a plan out that's generated by the Terraform plan command. So we have a great deal more flexibility when working with sort of plan out style inputs. Okay, so let's actually try to create a couple of rules. And again, some basic tips. I would recommend using planned out inputs for rule construction, at least wherever possible. And I would, if it makes sense in your context, I would strongly recommend that you consider creating a mono repo style monolithic Terraform artifact that you can use for rule construction if you want to have the broadest possible set of inputs you can leverage for creating new GSL rules. And something that may not always be obvious when you are relying primarily on CloudGuard managed rule sets as part of your assessment activities. Since this context preview is a very useful tool. It's built into the GSL builder. You can, as a search mechanism, you can put in partial strings and to try to locate properties of interest. And again, it gives you a full representation of all of the elements that are available to you that you can incorporate into a GSL rule, targeting this particular a Terraform resource definition for this particular resource. So let's see, S3 bucket. So context preview will give you an overview of all of the properties that you might be able to leverage. But an additional trick, which can be quite handy, would be to either execute rules like the following. And basically, it's an easy way to trick the posture management engine into enumerating the entire population of resources of that type that in this context would be the universe of AWS S3 bucket resources that have been defined in whatever Terraform artifact is being evaluated. And if you go to the trouble of creating a mono repo, so you've actually collected Terraform representations of all of your a representative public cloud environment, you might even want to create a rule set with a set of rules like this, and use that effectively to return all of the property values that you could potentially leverage in rules. So we know that versioning enabled, it's pretty simple when they're ACL grants. Let's take a look at seeing some of the values for some of these resources as specified in the resources that have been imported. So let's actually just look at a rule set with this form. Well, let's just actually execute the. In fact, let's just first add another bullet here. In fact, let's just add another bullet here. And give this kind of approach a look. So once I had completed the Terraformer import of this test environment, I took a look at all of the resource definitions that I was able to extract, and then basically created a series of rules that all have that form, should fail. So just to, as a means of pulling the parameter property values for all the resources that I was able to import. So let's just run this assessment, and again we'll use the imported Terraform content. And again, this assessment reports, when you, if you do consume them in the portal, we'll have the familiar look. Of course, these results are meaningless in and of themselves. When a predicate should fail, every resource of that type will be enumerated, but that's useful since that gives you a easy way to review the property values for every property that's defined in every cloud resource that was imported. So this can be quite handy for rule construction. Okay, now we'll just go back over and start working on some rules. Those are all pretty much the most important tricks. Let's go to, let's see here. Let's say we want to do something, we want to replicate something similar to the network security style GSL rules that you would find in most of our the rule sets that we published for live public cloud environments, something like AWS Security Group. Let's say we will target we'll develop something for that wants to limit the potential scope for unwanted access risk for databases. All right, let's edit this a bit. All right, let's have a look at how this actually works in practice when you try to leverage this kind of enumeration trick at scale. So here is a rule set that I created based on the content that I was able to import from our primary AWS demo environment. And let's go ahead, and it's just basically a long series of rules that with the same logical structure should fail on all of the resource definitions I was able to pull from this particular live environment. And let's execute it against the plan out artifact that I generated based on that import. So lots of material here for that can be leveraged to construct rules. Let's just go with something simple. Okay. So let's try to leverage these observations and use them to construct a rule of our own. Let's go with something that something like a network security rule of the kind where you frequently see in our CloudGuard managed rule sets that published that target live public cloud environments. Let's see where Ingress. It was for a very conventional kind of security group level network access check. All right. Let's see if we can elicit something. Okay. Well, this is just a basic idea of how rule construction works. There's one other trick I almost forgot to mention, and that would be to leverage the Terraform Graph command to generate a logical graph of logical relationships between Terraform resource definitions as they are as they are captured in the Terraform artifact that you selected for assessment. So Terraform Graph probably be somewhat familiar to most Terraform users. I believe it requires that you've also installed GraphViz. It's a very common graphing, very old, venerable graphing application. I'm going to generate a graph, and again, this is useful because it will help you. It will help to illuminate resource relationships, which you can then evaluate for consistency with your desired target state. And basically, you can create requirement and/or restriction-oriented rules around such relationships. You know which ones to look for that are prime candidates when you execute something like Terraform Graph. So let's go back to let's stick with the project for the sake of simplicity and run the most basic Terraform Graph. All right. I'm going to actually open that. That is not what I expected. Let's see what that produced. There. All right. So you can see here is a representation of the logical associations between different elements of the Terraform resource definitions. One clear candidate is the relationship here between a CloudTrail trail and the S3 storage bucket associated with this CloudTrail. Again, this is a relationship that is tested in one of the rules that we looked at briefly earlier that leverages our get resource syntax, which enables you to construct resource definitions, construct rule in fact, this relationship is one that's actually identified in one of the rules we looked at earlier when we were looking at ShiftLeft CLI commands. And it's one of the rules that leverages our get resource syntax, which enables you to define GSL conditions that span properties that are defined in more than one Terraform resource definition. So I'm just going to paste that rule in here. And this effectively says that a CloudTrail should not be stored in an S3 bucket that has an ACL that allows public ingress. So let's give this a test. Actually, let's first make sure we're targeting the right repository. Okay. And in fact, that is the resource we looked at in the repo earlier in the main TF definition. So there is that. So it's basically a sort of validates that this GSL logic is producing the expected desired result in this context. So that pretty much is the last tip I have. So I think in sum, the most productive approach to creating custom content, GSL content for evaluating Terraform pre-deployment artifacts would be to leverage as many of these options as you can. Try to use execution plan based assessment inputs. If possible, consider building a monolithic representation of your cloud resources, if only for the purpose of rule construction. Definitely make sure to leverage the built-in tooltips and other aids which are integral to the posture management GSL builder. Again, if you will be starting out with a fairly rich set of Terraform resources, you might want to consider just doing a baseline rule set just to enumerate all of the resources as currently defined to get a kind of a feel for the landscape that you'll be evaluating. And whenever you are unsure about the possibility of connecting dots between two kinds of conditions that are important for some security control that you'd like to implement, consider rendering a graph using Terraform Graph and looking for relevant relationships there. That's all I have for today. I hope some of what I've shared will be useful. Please feel free to reach out to your customer success representative or sales engineer if you have any questions about what was discussed today, and thanks very much for your attention.